Hello everyone, this is BB Hiramet. Today I am going to discuss that concept of ray optics. So following contents to be discussed today's class: introduction, reflection of light, laws of reflection, refraction of light, laws of refraction. How do we see the things? This is the one thing. How can we see the things which how it is visible to our eyes? So that is because of the reason. Here I'm going to explain with some basic introduction. See, light. So because of the reason we can see the objects is light. So first we should know that what is light. Light is a form of energy which enable us to see objects around us. When a light from an illuminated objects fall on our eyes, then an image is produced on the retina. As a result, cells in the retina get activated and a message is transmitted to the brain. Therefore, light is a agency that help us to see. There are many effects of lights, which are starlight sky, the multicolored rainbow, reflections in a pond, colored flashes from diamond and crystals, blue color of sky, mirage formation, looming, etc. The small part of the electromagnetic spectrum detected by the human eye is called as light, and wavelength range of this portion of electromagnetic radiation is about 400 nanometer to 750 nanometer. If the electromagnetic radiation having the wavelength range between 400 nanometer to 750 nanometer, so that range the electromagnetic radiations which our eye can detect. So presently accepted a value of a speed of light in a vacuum is 2.99792458 into 10 to the power 8 meter per second. So normally in generally we can call it as 3 into 10 to the power 8 meter per second. The speed of light in a vacuum is the highest speed attainable in nature. Light exhibits the phenomenon such as reflection, refraction, scattering, dispersion, interference, diffraction, polarization, etc. Like this. Here in the first figure, it shows the concept of reflection. In the second one, it shows the refraction. Here, this is a rainbow and a diffraction. There are different concepts are here. This explains the properties of lights, in which first one is reflection of light. Then what is meant by reflection here? The reflection nothing but it is a phenomenon in which a light of ray is sent back into the same medium from which it is coming on interacting with the boundary is called reflection. The boundary can be rigid surface or just an interface between two media. So like this, refraction is nothing but it is a phenomenon like this phenomenon in which a ray of light that is sent back into the same medium from which it coming. So this is an example for reflection. Then there are some laws of refractions are there. Laws of reflections are like this, in which first one, the angle of incidence is equal to angle of reflection. See, in the given figure, it shows like this. So incident ray is here, the red colored one, that arrow that shows that it is an incident light. So one which is incident on the mirror that reflect back to the same medium. Then, so according to first law of reflection that says the angle of incidence I that is equals to angle of reflection. This is the first law of reflection. Then come to the second law. The second law says the incident ray of light, reflected ray of light, and a normal drawn to the reflecting surface at the point of incidence lie on the same plane. So you see here the incident ray, reflected ray of light, and the normal drawn to the surface of mirror. So these three lines or the two rays and normal line which are lie in the same plane. This explains the second law of reflection. Then next concept about it is about the refraction of light. What is that refraction of light? Refraction is nothing but what? Here, refraction is nothing but refraction is the phenomenon of change in the path of light as it travels from one medium to another, which is called as refraction. See, once again, the refraction is the phenomenon of change in the path of light as it travels from one medium to another medium. When a ray of light is incident obliquely ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. See, then it can also, again one more definition is there. We can also express like this. The refraction can also be defined as the phenomenon of change in the speed of light from one medium to another medium. This is also one of the definition of refraction. See, in the figure that explains clearly about the concept of refraction. See, there are two mediums are here. One is rarer medium, another one is denser medium. When a ray of light which is incident from the rarer medium to the interface is nothing but a surface between two medium, and there is a slight change in the path. See, so slight change in the path like this, incident and refracted, nothing but there is a slight change in the path of light. Then again the ray of light travel from denser medium to rarer medium, again there is a change in path of the light. So this is what we can call it as refraction of light. Then here n is the normal line. I and R be the I is nothing but angle of incidence and R be the angle of refraction. See, again here there are two laws of refractions are there, in which first one, the incident ray normal to the refracting surface at the point of incidence and refracted ray all lie in the same plane. So this law is the same as that of the second law of reflection. So here, so first law of refraction explains like this: the incident ray, refracted ray, and normal to the refracting surface at a point of incidence lie in the same plane. This is the first law of refraction. Then what about second law of refraction? Second law of refraction explains like this: for a given pair of media, it's a plural word. Then like a two medium, another we can explain like this: for a given pair of media and for a light of a given wavelength, the ratio of the sine of angle of incidence to the sine of angle of refraction is a constant. This is the second law of refraction. For a given pair of media, the ratio of sine of angle of incidence to the sine of angle of refraction is a constant. So this explains about the law of refraction. Its formula is sine I divided by sine R is equal to n, where n is a refractive index of the media. Thank you.